Hey guys, Carter here at Patriot Training Center. Today I want to talk to you about bolt carrier groups in your AR-15. So the last video I did, I was talking about the top 5 mistakes that I see in store-bought guns. One of those big mistakes is improper building, gauging, things like that with the bolt carrier groups especially. So I'm going to go into that a little bit deeper and show you guys what some of the things that I see that are wrong with bolts and how we combat that here when I'm building a gun. So let's get started. Okay, so I'm sitting down here at my table and I'm going to just go over this bolt and show you a couple things that I see with manufacturers not doing it the right way and what we check for when we're looking at bolts. So first of all, quality manufacturer for the actual bolt. So there's not a whole ton of people that build or that actually make their own bolts. Usually they're bought and then rebranded. So even with that though, even if it is from a good manufacturer, sometimes their quality can slip. So you do have to gauge things and check for stuff. But one of the things that I do when I'm working on a customer's rifle is I go ahead and inspect. The biggest thing that you can usually tell is the gas key screws. So right here, this is your gas key on your bolt carrier group. And a lot of times these walls on the actual screws will be really thin, and that will tell you that they're probably very chintzy. So it's just a quick spot look of something that you can be aware of. If they don't have like thick walls on the screws, not great. The other thing that you can tell is if it's not staked properly. So as you can see here in this bolt carrier group, or on this gas key, you have staking right here. Basically what that does is after you torque it down to the spec, these screws are torqued down, you displace metal into the screws, and that makes sure that it stays staked in place and they don't come loose. If they come loose on a gas key, you're gonna have the gas from what is making the gun operate. It's going to start leaking out in your bolt carrier group, and then you'll have issues with it cycling and it won't run properly. So that is what you're looking for on gas key, is you want good screws here and good staking. That's one of the first things that you can be able to tell. So the next thing that I look for is the actual bolt material and how it's been tested. So as you can see here, it says MP, which is it's actually you'll see sometimes it'll say MPI, which is magnetic particle inspection, and then you'll also see it say HP, and that is MPI HP stands for magnetic particle inspection and high pressure. So that means that they're taking a high pressure round and testing to make sure that it will withstand that. This is MP, which is both of them. So this is also MPI and high pressure inspected. But if your bolt doesn't say MP on it or MPI inspected, then it could be a dud, or it could be not great. So that's one thing that I also look for, is what actual material are we using on these bolts, because this is a very important component of it. The next thing that I look for is coatings. So coatings are a big one. You can usually tell a lot about who made the bolt and like how good it is by what coatings they use. Usually your nitride and your phosphate are kind of your normal, what you see a lot of, and that's kind of the mil spec, and those are good. You also see some people in the quality space starting to go to some of the PVD coatings like DLC and things like that. But for the most part, nitride, phosphate, pretty good. I am not a huge fan of nickel boron because the properties can get sticky, and a lot of times they're just not great in quality. Anyone who makes the nickel boron bolts, if I put a gauge test to it, most of them fail. So I like to stick with the tried and true. And so coating is a big one that I look for, and seeing what people are doing there. The next thing I'm going to look for is actually when I break down the bolt, I'm going to check to make sure before I do that the gas rings are good on it. So sometimes out of the factory, which you don't see that often, but some of even like a factory bolt, the gas rings on the bolt, which I'll show you here in a minute what those look like, they collapse. So a bolt should be able to stand up on its own weight. You'll see it a lot when people are shooting guns a lot. You wear gas rings out. It's a replaceable component. If you take your bolt carrier group and set it on its face like that, if it collapses under its own weight, you need to replace your gas rings. So that's another thing that I just check for. Make sure that this is good, this is good. All right, let's take it apart and take a look at it. All right, so let's start with the bolt. This is your bolt and this is your bolt carrier. You can take it apart. You have your ejector, you have your extractor, you have your gas rings. These are the gas rings that I was talking about. That's what seals your gas from coming this way. So it keeps everything nice and sealed off and unlocks your bolt. So there's a couple big failure points in bolts. You have these two lugs right here. So you have 1 and 2 right here and right here. Those are right next to your extractor. These are one of the most common failure points in bolts. They'll just break off or they'll start to crack. And that is because there's not material holding it onto the other side. Like there's just a ledge right here, a machine ledge. So these get a lot of pressure and they will crack and break. So if the bolt isn't made out of good material, then you'll see those crack. Sometimes even like very high round count stuff that is of good material, you'll start to see them crack, but usually that's part of a bigger problem. The next place that you'll see guns break is right here. Now, if this is not sized properly and you have components that don't fit the right way, it will be fine in the first, few thousand rounds. But if you don't have the right material in the bolt and you don't have the proper size like cam pin and stuff that comes in here, then you'll start to see the bolt stretch right here. And as you can see, these walls right here are very thin. So if those start to stretch, it'll end up cracking and then your bolt will shear off right there. So right here and the bolt lugs next to your extractor are parts that will break on you. Now, this is what I was talking about when we get into store-bought guns. The cheaper store-bought guns will use crappy material on your bolt because they're trying to cut costs and things like that. The problem is that's fine when you're running in the low round count stuff, but when you really start running your gun, those problems will show up so bad. So that's the difference when you're talking about buying a $500 gun versus a $1,500, $2,000, $2,500 gun is this kind of stuff right here, not using the proper material in the bolt. That's what will make that gun run for thousands and thousands of rounds longer because they're actually spending the time to machine the right tolerances on this stuff and using the proper material and checking things. So that brings me into what I'm checking for when I look at this. So one of the things when I do an inspection on a bolt and any gun that I build, I use, as you can see here, these pin gauges to check different tolerances. So any gun that has my stamp of approval and my name on it actually goes through a bolt inspection test. Now, that's taking an already good bolt using good components and double checking everything. So just because it's a good material and good manufacturer does not mean that it's perfect because people miss QC stuff all the time. So what I do is I go through and check everything to double check and make sure that everything is what we want it to be and all the tolerances are right. So for instance, this bolt has my mark of approval. I've already inspected this one and measured things out. And so I put a white paint pen mark right here. I just did a batch of 20 of these for our PTC Armory guns that we're building. But in that batch of 20, I found one of these that was actually bad. So this is a good manufacturer, one of the best. Most of your high-end bolt carrier groups are this company who makes them. But this one had a problem with the gas key. So the gas key is actually, the screw was under torqued. Now the way that I check this is on every single one, I actually reverse torque it. So the torque spec on these is around 50 to 58 inch-pounds. But this one right here, I do a reverse torque on it using my torque wrench and I reverse torque them at 35 foot-pounds. So I put 35 pounds of pressure to torque it off, and if they break, then they were under torqued. So I'll show you right here. I think it was this front one, but what I did is I put 35 foot-pounds of torque. Oh, yep, so there it came loose. It clicked once because I re-torqued it on there, but I didn't restake it. But the first time I actually tried to put that amount of torque on it, 35 foot-pounds, then it broke off. So I checked them at that, make sure that they're torqued back on and all proper there. But this one did not pass because the screw came loose and it wasn't torqued on properly. Now, most of your manufacturers will not look at that sort of thing. They're going to buy bolt carrier groups and they're going to say, yep, looks good enough for me, and they're going to throw them in your guns. And it probably won't matter for the first few thousand rounds, but the more you shoot them, the more of those problems are going to start to come up. So what we're doing, because we obviously can't test fire 6,000 rounds through each gun, I'm going to gauge everything like this and try and catch those problems before they were to happen. So most people would get this bolt in their gun, and then they would shoot it 5,000 rounds, and then their gas key would come loose. And that would really suck because they'd have to send it to a gunsmith, or if they know what they're doing, either replace the bolt or whatever. So that's what we're checking here, and that's why I'm going through those inspection processes. Another thing that I'm checking is your gas key fitment. So this is where your gas comes from your gas tube into your gas key and pushes the carrier and also unlocks the bolt. I'm checking the fitment right here, so making sure that this is right. There's 3 dimensions that I'm checking inside this carrier. I'm checking bolt support, I'm checking gas ring run, your bolt tail run. I'm checking outside diameter of this compared to your bolt tail versus your bolt tail run. Things of that nature that you would never think about, but those can all go into what makes a good bolt carrier that's going to last you thousands and thousands and thousands of rounds and make your gun actually work in all conditions, or at least most conditions. So that's what I'm looking for in bolt carrier groups. And I see a lot of companies trying to skimp out on this part, but it is really one of the most important parts. Your bolt carrier group and your barrel are your most important parts of the gun. That is your lifeblood. That is what is the operating system of your gun. So you have to spend the money on that. And that's what you're looking out for. So that's not everything that I do for the inspecting the bolt, but that's just showing you some of the things that I do like to look for, and showing you why a $500 gun costs $500 and a $1,000 gun costs $1,000 or whatever. Make sure that you're putting really good parts in your guns, and make sure it's someone who knows what they're doing when they're building your stuff, if you're having it built, and make sure that you spend the right kind of money on guns and know what you're actually buying, looking at the components, seeing if they're right. So those are just some of the things that I look for when I'm looking at bolt carrier groups. Let me know if you guys found that video helpful. Ask me any questions in the comment and I'll answer them. I'll catch you guys in the next one.